0, y is an odd multiple of pi by 2. Okay, so these are the two conditions. Dou z by dou y equal to 0, uh, dou z by dou y equal to minus 2 sin y, and when x equal to 0 and z is equal to 0 if y is an odd multiple of pi by 2. So let us see how to solve these. Okay, so here they have given okay dou square z by dou x dou y is equal to sin x into sin y. Okay, so here first how to write it in notation form, let us see. Okay, dou square, sorry, here dou by dou x of dou z by dou y. I can write like this. Okay, so this one is equal to sin x into sin y. Correct. So now what I will do is first I will integrate with respect to x. But if you integrate with respect to x, yes, dou z by dou y will do. Okay. So integrate with respect to x. What happens? Dou z by dou y, or we can have this statement here. Integrate. Wait a minute. Solution. Now let us observe. Integrate with respect to x on both sides. Okay, if you integrate this one with respect to x on both sides, what happens? Dou z by dou y is equal to, here how much you'll get? With respect to x, you are integrating. So sin y will be constant, integral sin x dx. Okay, so implies dou z by dou y is equal to sin y. Integration of sin x is how much? Yes,
minus cos x.
into minus cos x. Okay, plus here some integrating constant you have to put. Instead of putting number, I will put arbitrary function. So the arbitrary function is here f of y. Okay, since we have integrated with respect to x, we have to put the arbitrary function as function in y. Okay, so dou z by dou y is equal to minus cos x sin y, okay, plus f of y. Now we have to integrate with respect to y. Integrate with respect to y. Okay. Integrate with respect to y. What happens? Z is equal to how much? Minus cos x integral sine y dy plus integral f of dy. Okay. So what happens? Z is equal to minus cos x into integration of sine y minus cos y plus this integration f of y, small f of y, I can write it as capital F of y. Okay, plus arbitrary function I can put it as g of x, because we have integrated with respect to y, we have to take other variable as arbitrary function, so g of x is an arbitrary function. Okay, so finally what is the solution? Z is equal to minus into minus plus, you get cos x into cos y plus capital F of y plus g of x. Okay, so now I need to find the solution with these unknown functions. Okay, so if you want to find this unknown function, we have to make use of given conditions. Okay, so condition 1, what is there? We'll see. Condition 1. Okay, condition 1 is nothing but dou z by dou y is equal to minus 2 sine y when x equal to 0. Okay, so dou z by dou y, where we'll get this equation? Instead of writing this as equation 1, I'll write it as equation 2 and take this as equation 1. Okay, so from equation 1, okay, so dou z by dou y value is how much? Let us write it. Minus cos x into sin y minus cos x into sin y plus f of y is equal to how much they have given here? Minus 2 sin y. So minus 2 sin y. So this is when x equal to 0. So in the bracket take x equal to 0 here. So I'll substitute this x equal to 0 in this function. What happens? Minus cos 0 sin y plus f of y is equal to minus 2 sin y. Okay, so cos 0 is how much?
1.
Cos 0 is 1. So you'll get to minus sin y plus f of y is equal to minus 2 sin y. If we send this minus sin y to that side, f of y will be minus sin y, because minus 2 sin y plus sin y. So minus 2 plus 1, it is minus 1. So we got f of y equal to minus sin y. But if you observe equation 2, what we want? Capital F of y. Capital F of y is nothing but integration of f of y. So integrate on both sides. Integral f of y is equal to minus sin y dy. So this is nothing but capital F of y, which is equal to minus of minus will get plus cos y. Okay, so we got capital F of y as cos y. Okay, substitute this cos y in equation 2. So we write this as equation 3. Okay, substitute equation 3 in equation 2. Okay, so if you substitute 3 into, what happens? Z is equal to cos x cos y plus capital F of y. So capital F of y is cos y plus g of x. Okay, so take it as equation 4. Okay, now apply condition 2. Okay, from condition 2, so what is this condition 2 actually? Condition 2 is nothing but when z is equal to 0, take y variable as y equal to 2n plus 1 pi by 2. Okay, so take z is equal to 0, that means from z equal to 0, then y is equal to 2n plus 1 into pi by 2. Okay, so let us see how to do this. From equation 4, so from equation 4, take z is equal to 0 on the left hand side is equal to cos x into cos of 2n plus 1 into pi by 2 plus g of x, sorry, plus cos y, that means cos of 2n plus 1 divided by 2 into pi plus g of x. Okay, so 0 is equal to cos x you keep as it is, into what is cos pi by 2? Cos pi by 2 means cos 90.
Zero.
Yes, this is 0,
Zero,
right?
zero.
So whatever the multiples of pi by 2 all become 0. So here 0 plus 0 plus g of x. So implies we got g of x as 0. Implies g of x we got it as 0. Okay, so therefore take it as equation 5. Substitute equation 5 in equation 4. Therefore z is equal to, substitute this one, we'll get cos x into cos y plus cos y plus 0. So implies required solution is z is equal to cos y, you can take common, into cos x plus 1. So this is the required solution which we want. Now observe this question. This is also like same. This question I will do. Next question I will give it as homework. Just try it. So here they have given dou square z by dou x square is equal to xy. Okay. So here the conditions are this one, dou z by dou x when log of 1 plus y when x equal to 1, z equal to 0 and x equal to 0. So how to represent it in notation form? Dou z by dou x square. So this is nothing but dou by dou x of dou z by dou x, which is equal to xy. Now integrate with respect to x. Integrate with respect to x. What happens? Dou z by dou x is equal to, so here we are integrating with respect to x. What happens? Y into integral x dx. Okay, y into integral x dx. So dou z by dou x is equal to how much? Y into x square by 2 plus integrating constant as f of y, because integrated with respect to x, other variable as arbitrary function will do. So now dou z by dou x is equal to x square y divided by 2 plus f of y. Okay, take this as equation 1. Now again we will make use at the end. Otherwise you can make use of this condition and you can find f of y also. Okay, so you can write equation 1. What happens? Let us find f of y. Dou z by dou x is equal to log of 1 plus y. Okay, when x equal to 1. So from this x square y divided by 2 plus f of y at x equal to 1 is equal to log of 1 plus y. Okay, now substitute x equal to 1 here. What happens? 1 square, so you'll get y divided by 2 plus f of y is equal to log of 1 plus y. Okay, so implies f of y will be how much? Y by 2, sorry, log of 1 plus y minus y by 2. Fine. So finally we got f of y as this much. So therefore from equation 1, what happens? Dou z by dou x value is x square y divided by 2 plus f of y is log of 1 plus y minus y by 2. Okay, now integrate with respect to x and check. So if you integrate with respect to x on both sides, what happens? Z is equal to uh, y by 2 will be constant, integral x square dx plus log of 1 plus y will be constant, integral dx minus y by 2 is constant, integral dx plus g of y is one more arbitrary function. Okay, so z is equal to y by 2 into x cube by 3 plus here integration of dx is nothing but x log of 1 plus y. minus xy divided by 2 will get plus g of y. Okay, you can take this as equation 1. This is, you can take 2. This as equation 3. This as equation 4. Okay, so therefore from equation 4, z is equal to x cube y by 6 plus here x log of 1 plus y minus xy by 2 plus g of y. Okay, so instead of writing this directly, you can write this as equation 4. Now apply next condition. Condition 2. So what is condition 2 actually? Z is equal to 0 when x equal to 0. So from equation 4, put z is equal to 0 in the left hand side is equal to, substitute x equal to 0. 0 into y divided by 2, sorry, divided by 6 plus 0 into log of 1 plus y minus 0 y by 2 plus g of y. Implies what happens? All become 0. G of y is 0. So therefore, take this as equation 5. Substitute equation 5 in 4. What happens? Z is equal to x cube y by 6 plus x log of 1 plus y minus xy divided by 2. So this is the required solution we need. Take the previous problem as homework. Okay. So here, what is given? Dou square z by dou y square is equal to z. Okay. These two are independent variables. You can take all the variables to the left hand side. So dou square z by dou y square minus z is equal to 0. Okay. Implies d square minus 1 into z equal to 0, where d is equal to dou by dou y. Okay, so d square is nothing but dou square y by dou x square, dou y square. Okay, so now we'll solve this as usual by using ordinary derivatives. So what is auxiliary equation for this? So auxiliary equation is m square minus 1 equal to 0, implies m square is equal to 1, implies m is equal to plus or minus 1 will get. Okay, so what is the complementary solution for this? When m has different solutions, distinct solutions. Yes.
C1 e power x plus C2 e power minus.
P1 e power, here y is there, right? So e power 1y plus c2 e power minus y is there. Okay, but here we are using partial derivatives. So instead of c1 and c2, we'll get functions in x. Okay, so therefore z is equal to c1 you replace with f of x, c2 you replace with g of x. Okay, so f of x into e power y plus g of x into e power minus 1. Okay. Now make use of conditions in this one and solve it. Okay. Take it as equation 1. Use the condition. First condition is what? Y equal to 0, comma, z is equal to e power x. So substitute z is equal to e power x from equation 1. E power x is equal to f of x will be as it is e power 0 plus g of x e power minus 0. So e power x is equal to f of x plus g of x. So take it as equation 2. So using the condition 1 we have got this. Next use the condition uh, what is the next condition? Take y equal to 0 and dou z by dou y is equal to e power minus x on equation 1. Okay. So first find out what is dou z by dou y. From equation 1, dou z by dou y is equal to how much? F of x into differentiation of e power y is also e power y plus g of x into differentiation of e power minus y. It is minus e power minus y. Okay. Now apply y equal to 0 in this. So dou z by dou y at y equal to 0. What happens? F of x minus g of x. Okay, otherwise we can write it as e power 0 plus g of x, sorry, minus g of x e power minus 0. So in the next step, what is there? Actually, this is e power minus x. So e power minus x is equal to f of x minus g of x. Take it as equation 3. Okay. Now, if you take equation 2 plus equation 3, what happens? You get 2 into f of x is equal to e power x plus e power minus x divided by 2. Sorry, e power x plus e power minus x will get. F of x is equal to e power x plus e power minus x divided by 2. This can also be written as cos hx. Okay, so implies f of x we got it as cos hx. Similarly, equation 2 minus equation 3 implies 2g of x is equal to e power x minus e power minus x divided by, sorry, this much will get. Now g of x is equal to e power x minus e power minus x divided by 2, which can also be written as sin hx. Okay, so therefore from equation 1, the solution is z is equal to f of x cos hx e power y plus sin hx e power minus y. So this is the required solution which we need.